Hello and welcome to House Building Digest series number 12, which is on prevention of dampness. My name is Dr. Shailesh Agrawal, Executive Director of BMTPC. Through this digest series, BMTPC is reaching out to the common man to provide useful information about various essential activities involved in house construction, including technical and non-technical matters associated with building materials and construction technologies. Every individual has a dream of owning a house, and through this series, we will slowly unravel myths and misconceptions about building construction. The language used here is simple so that it is understood by one and all. A house should be constructed in a manner that it does not allow or prevent or at least minimizes the ingress of moisture within. In other words, the building should be dry once it has been occupied. It calls for adequate precautions during construction as well as during its occupation. Otherwise, it leads to dampness of various elements of the house, causing unhygienic environment. Damp environment is also the root cause of various diseases like pneumonia, rheumatic fever, common cold, etc., to name a few. It also precipitates damage to walls, plasters, paints, floors, roofs, which end up in foul smells and unhealthy, unhygienic living conditions besides being unsightly. Termites also tend to grow in damp environment, which affect the furniture, clothes, books, documents, etc. Dampness can occur on account of rain, which strikes on the exposed surfaces of the house and finds its way within through the walls and joints, etc. It can also occur if proper precautions are not taken in its architectural or engineering design, use of inferior quality of materials, bad workmanship, insufficient supervision, and non-adherence to the construction specifications. It is therefore becomes essential that all the necessary measures should be taken to prevent dampness from entering the house. These measures start from the design stage and have also to be undertaken during construction and subsequent occupation. Accordingly, the house should be maintained properly and the defects uh, rectified as and when noticed. The treatment given to prevent leakages in the house are generally termed as waterproofing, whereas treatment given to keep the wall, floors, basement dry are termed as dampproofing. The house owner is advised to seek the help of an architect or an engineer for carrying out waterproofing and dampproofing in the house. Let's discuss the defects. The defects caused by dampness can broadly be summarized as under uh, growth of termites, occurrence of efflorescence, which ultimately results in disintegration of bricks, tiles, stones, or any other cladding material, softening of plaster, bleaching and flaking of paints with formation of colored patches, corrosion of metals, deterioration of floors and roofs, deterioration of electrical fittings, rotting of timber, breeding of mosquitoes, unhealthy living conditions. Moisture absorption in the structure of the house is one of the chief causes of dampness. It may occur on account of penetration of rainwater or on account of defective construction. The coarse and granular nature of building materials results in the moisture finding an easy access through the voids therein, and this aided by capillary action assists the moisture to travel in different directions. Moisture may find its way to the interior of the building either through the foundation and plinth, walls, chhajjas or sunshades, and floor, or through the roof. Moisture can also come from leaking pipes, waste or overflows, rain seeping through the roof on account of cracks or defective joints, rainwater penetrating around door and window frames, or a leak through fixtures and uh, joints. Broadly, dampness can occur in a house on account of following regions: dampness rising through foundations, splashing rainwater on the walls, penetration of rainwater through unprotected tops of walls, parapets, etc., inadequate slopes in flat roofs, defective terracing on roofs, and improper rainwater pipe connections, defective junctions between roof slabs and parapet walls, condensation of atmospheric moisture, leakages in wet areas of a building like kitchen, bathrooms, WC, etc. Building science has come up with a number of methods for the prevention of dampness in a building. These methods can broadly be classified as membrane dampproofing, integral dampproofing, surface treatment, Guniting. Let's look at them one by one. Membrane dampproofing consists of providing a layer of water repellent material or a membrane between the source of dampness and the element of the structure. This type of a layer is generally known as dampproofing course or DPC. It may comprise of materials like bitumen felt, mastic asphalts, polymers, plastic or polythene sheets, cement concrete, etc. Integral dam proofing is a process of making certain building materials impervious such that water is unable to penetrate through it. This generally involves adding of specified dam proofing compounds in cement for the concrete or mortar mix. Such compounds are available in the market in powdered as well as liquid form. The quantum of waterproofing compounds to be added in cement depends upon the manufacturer's recommendations. Generally, 1 kilogram of such a compound is added per bag of a cement. Surface treatment consists of filling up the pores of surfaces which are subjected to dampness. Since bricks display the property of porosity, surface treatment in form of plastering is usually resorted to prevent the dampness. One of the commonly used plaster is the lime cement plaster, which consists of cement, lime, sand mixed in proportion of 1:1:6. Brick surfaces or even plastered surfaces can be provided with water repellent paints, which are quite effective in protecting the building against the ravages of heavy rainfall. The house owner is advised to discuss the issue with the architect in order to adequately protect the walls from the ingress of moisture. Guniting is a process of providing a waterproofing treatment in a house by way of deposition of an impervious layer of rich cement mortar over the surface to be waterproofed. It is usually carried out in basements to prevent ingress of groundwater into the structure. The process is quite costly and is carried out by spraying of a mixture of cement and sand under pneumatic pressure using a machine called cement gun as shown in the picture on your right hand side. Guniting is also done on other surfaces like floors, etc. To provide an impervious layer below. It is also done for rehabilitation of existing structure, retrofitting or strengthening of weak structures, etc. The process of providing dam-proof arrangement in a house commences right from the planning stage when the specifications are being drawn up. The measures to be taken are largely dependent upon the site conditions, climate conditions, and also the budget of the house owner. The measures to be undertaken during construction of a house include treatment of foundations and plinth, treatment of floors, treatment of walls, treatment of flat roofs, treatment of parapets. Let's understand them one by one. Treatment of foundations is dependent upon the groundwater level on which the building is to be constructed. Precautions should be taken to provide the plinth level of a house above the level of a road in order to prevent the surface runoff from the road entering into the house. The requisite characteristics of a healthy site for house include a dry, porous, permeable soil, a low and non-fluctuating groundwater level, and a soil retaining very little dampness which is free from organic impurities. Exposure to sunlight and free circulation of air are also requisite for prevention of dampness. A damp proofing course is provided all along the plinth level of the house to arrest the ingress of moisture from the foundations to the superstructure walls. Provision of DPC includes cleaning up of the horizontal brick surface at the plinth level, applying a hot coat of bitumen, and then laying a 40 mm course of cement concrete in the ratio of 1:2:4. The superstructure walls can then be constructed over this DPC. The dam proofing course may also consist of asphalt, sheet bitumen, a double course of slates in cement or stoneware slabs, especially made for the purpose. In areas where water table is usually low, the normal methods of providing floors at the ground level are adopted. However, in areas where the subsoil water level is high, it is advisable to provide DPC in form of a flexible member like bitumen felt, etc. below the floors at the ground level. Superstructure walls are most vulnerable to ingress of moisture as they stand totally exposed to rain. This is primarily on account of water absorbing capacity of bricks and seepage of water through the mortar, bond and plaster. As the water travels from the outer unsightly damp wall to the interior surface of the wall, they end up becoming damp. This leads to unsightly appearances, peeling of plasters, paints, etc. Dampness also result in unhealthy living condition, which is harmful for the occupants of the house. Generally, the walls of house are liable to become damp by virtue of water rising in them from damp earth and foundation, rain falling directly upon the exteriors of the walls, leaking pipes and other connections, water seeping through the exposed top surface of the walls. The water rising from the damp earth or foundation is prevented by the provision of TPC at the plinth level, whereas exterior walls can be protected by providing an interface like plaster or paint, etc. Leakages from pipes or fittings can be on account of improper jointing, which should either be taken care of during the construction stage or should be maintained properly at post-construction stage. If proper plastering is done or other such adequate measures are taken to cover the exposed top surfaces of the wall, seepage can be prevented from entering the walls. In any case, in order to prevent dampness from entering through the walls of a house, it is necessary that they should be constructed of sound materials, as porous bricks and weak mortar readily absorb moisture they come in contact with. Along with the materials, the workmanship should be proper and the brick bond be laid properly and the mortar joint properly staggered. Finally, curing of exposed brick work and plaster should also be carried out for the required duration. The normal precautions for the prevention of dampness in walls include pointing, plastering, and painting on brick surfaces. In areas subject to high rainfall, it is advised to provide cement plaster in proportions of 1:4 mixed with waterproofing compounds. Such compounds are readily available in the market and have to be mixed with cement in the recommended proportions. Another way is to paint the plaster with waterproof cement paints. In addition, the window sills should stand out beyond the face of the wall and have a small groove on the underside of the projection. This groove breaks the run of the water towards the wall. The shades provided in the house should span beyond the width of doors and windows. This shade should also be provided with a groove at its underside to break the path of the water, also known as drip course. Flat roofs are also prone to ingress of dampness in a house, and due care has to be taken in providing a waterproofing treatment on them. The treatment has to serve a twofold purpose, which includes waterproofing as well as thermal insulation. Rainwater should not be allowed to stagnate on the roof, and accordingly, proper slopes and rainwater pipes should be provided to drain out the water effectively. Normally, a slope of 1:40 to 1:60 is provided for RCC roofs. These slopes can be provided in the waterproofing treatment proposed to be provided over the RCC surface. Further, for every 30 square meter of roof area, one rainwater pipe of 10 centimeter dia or 4-inch dia is expected to be adequate. Hence, if the roof area of your house is 120 square meter or 1200 square feet, 4 down pipes of 10 centimeter dia would be required to drain out the water from the roof. These pipes have to be provided at such places on the roof which would enable the rainwater to drain out in an effective manner. On the flat roof, waterproofing treatment can be provided in a number of ways, which generally include the following: laying of bitumen felt, lime concrete terracing, lime concrete with tiles, mud fusca with tiles, brick Coba treatment, and chemical treatment. Let's understand them one by one. In laying of bitumen felt, the roof slab Surface is first cleaned and surface is painted with hot bitumen. Layers of bitumen felts are then laid over it. Depending upon the type of building and climatic conditions, the treatment of felt may be in 4, 6, or 8 courses. In moderate climate, a 4-course treatment is considered adequate. On the final layer of the felt, bitumen is painted again and pea-sized gravel or grit is spread to get the desired surface. Lime concrete terracing is best suited for zones having hot and humid climate conditions, especially those close to sea. In this case, a 10 centimeter average thickness of lime concrete is directly applied over the roof surface. Neatly finished tile terracing providing adequate slope for draining out the water. The surface is then allowed to dry and a coat of hot bitumen is then applied. If need be, bitumen sheets can also be laid over the surface so obtained. Such a type of waterproofing, which is the lime concrete with tiles, is usually provided if the terrace is expected to be used by the occupants for sleeping or any other such purpose. In this case, the top of the roof surface is first painted with hot bitumen and a layer of coarse sand is spread. While the bitumen is still hot, lime concrete layer of average 10 centimeter thickness is then applied, providing the slope therein. The layer is then compacted and 2 courses of tiles are provided with the joints being pointed in cement mortar of 1:3 to get an even surface. Treatment with mud fusca and tile is best suited for areas in hot and arid regions like Delhi, UP, Punjab, etc., where the annual rainfall does not exceed 1000 mm. The treatment normally consists of painting the roof surface with hot bitumen, followed immediately by spreading coarse sand. While the bitumen is still hot, mud fusca treatment is then applied, which consists of puddle clay mixed with straw or bhusa. The soil for mud fusca should be free from gravel and coarse sand, vegetable material, and fine concrete particles. The soil should also be free from harmful and efflorescent salts. The surface so obtained is plastered with a mix of clay and cow dung in 1 or 2 coats. Tiles are finally laid on the plastered surface and the joints are grouted with cement mortar of 1:3 to get the required surface. Brick Coba treatment is suited for areas which have moderate to heavy rainfalls. In this case, the roof surface is first cleaned and a thick layer of mixture of cement and acrylic based chemical is first laid. This is followed by providing a layer of brick bats in cement mortar of 1:4 ratio. After curing the layer for about 2 days, another coat of brick bats is in cement mortar 1:4 is provided. On this surface, a thick layer of cement mortar 1:4 is provided, which is finished smooth. It is always advisable to mark squares on this surface of typical dimensions, let's say 300 mm by 300 mm. Finally, curing is carried out for about 2 weeks before putting the terrace into use. Chemical treatment. Roof terraces can also be treated for waterproofing by providing a chemical treatment on the surfaces. It can also be used for waterproofing of concrete and cement and mortar in basements, water retaining structures, external plastering, bathrooms, balconies, water tanks, sumps and drains. The method of application, however, varies with location at which waterproofing is to be provided. The chemicals are usually in liquid or powder form or in the form of a membrane. They are available in the market and are to be strictly used as per the recommendations of the manufacturers. As far as liquid or powder is concerned, the same are available in form of surface applied treatments or admixture technology. The former is to be applied directly on the roof surface and the later is to be mixed with cement as a plaster on the concrete surface. Products are also available as admixtures to be mixed in concrete being used for the roof slab. Normal insulation waterproofing layers are then provided over the surface so obtained. Another type of chemical waterproofing is done by providing a chemical membrane. In this case, a 5-layer or 7-layer treatment is provided depending upon the average rainfall in the area. Typically, a 5-layer membrane treatment would consist of the following. First, application of first coat of bitumen primer, then providing a coat of bonding material, then laying of acrylic polypropylene modified polymeric membrane, then providing another coat of bonding material, and then providing top layer of surface finish, say brick tiles. The surface on which the treatment has to be applied, has to be cleaned properly before application of the treatment. The house owner is advised to have the opinion of architect or engineer before going in for chemical waterproofing treatments for roofs. Water usually tends to seep through the joints between the parapet walls and roof, and therefore it is very important that adequate precautions are taken to treat parapets and roof joints. Otherwise, dampness will occur on the wall surfaces as also the underside of the roof slab. The treatment in this case can be provided as per the normal waterproofing methods carried out for the flat roof. In cases where lime concrete terracing is carried out, a 15 centimeter half round gola of lime concrete is provided at the junction of the roof and parapet where asphalt layers are provided. The asphalt layer is turned up into the parapet wall for at least up to 15 centimeter, thereby covering the junction of roof and the parapet. Parapet walls require careful detailing. At the top of the wall, it is good practice to provide a weathering coping. Ingress of rainwater from the top of parapet can be restricted either by coping or by providing a waterproofing course, which is very important. There is another important component which is khurra. Khurra is an essential feature for allowing the water flowing from the roof to flush out, thereby preventing the rainwater to seep into the roof slabs. It is a depressed proportion in the roof just before the outlet of rainwater pipe. A khurra is generally 45 centimeter by 45 centimeter in size. Khurras are constructed before the brick masonry work in parapet wall is taken up and is normally provided in cement concrete of 1:2:4 mix, where 1 is cement, 2 is coarse sand, and 4 is stone or stone aggregate of 5 centimeter thickness or other mix as may be specified by the architect. The concrete for the khurra has to be sloped uniformly towards the rainwater outlet. A thin membrane in form of plastic sheet or aluminum sheet, etc., is provided before laying the concrete for the khurra. The top surface of the khurra is kept lower than the level of adjacent roof surface. The sides of khurras and the sides of the outlet opening are well rounded. The house owner is advised to discuss with architect regarding the provisions of khurra in the house. Waterproofing of wet areas. Wet areas in a house are those areas which are likely to get wet during its occupation. Typically, these includes bathrooms, toilets, and kitchens. In the kitchen, the wet area is largely localized as water gets directed to a specified area. Toilets and bathrooms are different in that considerable quantities of water are consumed and flow through them each time they are used. Special waterproofing treatment is therefore required in such areas. In areas where a WC seat is to be provided, the normal floor slab is depressed to the specified extent, and adequate waterproofing treatment is done on the horizontal and vertical surfaces of the depressed portion. The horizontal and vertical surfaces of the slab concrete are hacked and cement slurry, preferably prepared with waterproofing compound, is first applied. Cement plastering in proportion of 1:3 is then done with waterproofing compound mixed in the cement. On drying of the surface, a specified quantity of bitumen is applied on both the horizontal and vertical surfaces, followed by sticking a PVC sheet on the surface. WC sheet is then fitted and the filler material is placed around it up to the desired level. Base concrete is laid thereon and normal flooring is then done over it. This floor level is kept slightly below the level outside of the WC to prevent the water from WC to spill out. Similarly, in the bathrooms, normal waterproofing measures are taken, and in addition, tiles are provided up to a height of, say, around 7 feet above the floor. This prevents the splashing water from dampening the wall surface. This treatment is also termed as deado. At last, occurrence of dampness in a house is common if adequate precautions are not taken during its construction. Dampness leads to unhealthy living condition, unsightly patches on walls and ceilings, etc. And it also leads to an increase in cost of maintenance. The measures written here would go a long way in preventing dampness to enter into the house. First, provision of a damp-proof course or DPC at the plinth level, adequate waterproofing treatment at the roof levels, provision of parapet walls with coping, providing gola as explained you earlier at the junction of roof slab and parapet, provision of khurra as explained earlier for proper draining out of rainwater from the roof, providing adequate number of rainwater pipes to drain out water from the roof, provision of waterproofing treatment on the depressed portions of the slab in wet areas, proper jointing of pipes, jointing of doors and window frames adequately with the walls to prevent seepage of water, provisions of sunshade with grooves or drip course along the edges, use of good quality materials for construction and good workmanship, inspection and proper maintenance of the house. The house owners is advised to discuss the issue of prevention of dampness with the architect, engineer, as well as the contractor responsible for construction of the house. I hope this building digest number 12 will be useful for creating awareness about the construction of the house and can be downloaded from our website www.bmtpc.org. This completes the House Building Digest series, which comprises of 12 parts. I hope it will help you when you venture to construct your house. Thank you very much.